All right, you guys let me know if I lose you at any point. All right, but this is what we did in class on Tuesday. So it says we want to draw the angle in standard position. So I'm thinking I've got like a coordinate graph. And I'm going to graph it at -5, -4. So in terms of plotting that point, -5, -4 is here. So what you want to do to create what's called your terminal side is you want to connect 0, 0, which is the origin, to that point. So I'm going to go from here to here. And that's the line that I'm plotting. And then from there, I want to create the reference triangle. The reference triangle is always created with the x-axis. So if you're on the left-hand side, you're going to use the left-hand x-axis. If you're on the right-hand side, you're going to use the right-hand x-axis. So I'm going to go like this. And then you also need to drop that straight down. And so this creates the right triangle. And then your reference angle is this angle in the corner, and that's called theta. All right, so that's what the reference triangle looks like for this one. And then I just kind of think about, well, what do I know? Well, I went over 1, 2, 3, 4, 5. So this is 5 units. But because it was to the left, I'm going to put a negative on that. And then I went down 4 to get to this point. I went straight down. I didn't go like diagonally. This isn't 4. This is 4. And because I went down, that's -4. All right, so that's just the direction, the negative symbol. So in terms of the triangle, that's the pieces that you know. And so the third piece is the hypotenuse. You can figure that out with Pythagorean theorem. So I'm going to do 5 squared plus 4 squared equals c squared. You could do -5 squared plus -4 squared equals c squared, or you can leave the negative. +5 squared and -5 squared are the same number. It doesn't matter. All right. So I end up with what? 25 plus 16, so 41 as our hypotenuse, and then I'm just square rooting that. So my hypotenuse is the square root of 41. We okay with that? Anybody have questions? All right, so when I am filling out sine, cosine, tangent, I am thinking SOHCAHTOA. Sine is opposite over hypotenuse. Opposite of what? The green angle, right? So all of these are going to be based on the reference angle, theta, because the question's saying let theta be the angle, right? So we're trying to figure out what that is. So the opposite of the green angle is -4, and the hypotenuse is √41. And then I could flip that to get the cosecant, because the cosecant is just the reciprocal of that, which means flipped fraction. All right. And then I'm going to have to rationalize the one with the root on the bottom. I don't have a crazy a lot of space, but I'm going to multiply by √41 over √41. So I'll get -4 √41 over 41 as my final sign. Can't have the root in the bottom. That part, the rationalizing, is not a crazy big deal, okay? I care that you know what the sign is. You should rationalize it. If you don't rationalize it on a quiz, it might be like a half a point, okay? You're not going to lose the entire thing. You know the idea, right? That's what I want you to know. Technically, you can't have a root in the bottom, so you do have to rationalize it, all right? Cosine is adjacent over hypotenuse. So next to the green is a -5, and the hypotenuse is √41. And then the reciprocal of that would be the secant. So I'm flipping that fraction, and I get that. And again, that cosine has a root in the bottom, so I have to rationalize it. I'm going to skip the step where I show the multiplying, because I just don't have space. But you end up with this. -5 √41 over 41. All right, and then tangent is opposite over adjacent. So opposite over adjacent is a double negative, and so the negatives cancel out and make this positive, so it's really 4/5, not -4/5. And then I'll flip that for cotangent and make that 5/4. You don't have to do this, but a way to check your symbols at least is we learned this thing called all students take Calc, and we're here in quadrant 3, which means tangent should be positive, but everything else should be negative. And so you just check your symbols. This should be negative, this should be negative, this should be positive. So you'll see we've got a negative in this answer, we've got a negative in this answer, we don't have any negatives here. So that's just like a reinforcement of your answer, you don't necessarily need to do it. But if by any chance you forgot to call that -5, you could throw the negative in now. All right, so now you have 6 different options, 3 of which you can put into your calculator. Your calculator has a button for sine, cosine, and tangent. So to find the theta, you're going to use the inverse of one of these. It's your choice. I see that tangent's definitely the easiest because it's just 4/5. There's no radicals with that. So to find this tangent, I'm going to do the tangent, or sorry, this theta, I'm going to do the tangent inverse of 4/5. You just have to make sure you're in degree mode. Okay, if you're not in degree mode, you won't get the right answer. So my calculator is not in degree mode because I just reset it. So I'm going to put it in degree mode. And I'm going to do the tangent inverse of 4/5. That's going to give me my reference angle. So we'll call that 38.66. I just changed the words of this because it said now write it in radians. If you needed to find it in radians, literally the only different thing that you would do is hit mode and change it to radian mode and do the exact same thing. I don't really care that you can do that. That seems like a really simple task. What I care is, can you take that angle and tell me what this one is? So the standard angle, we'll do it in orange, is from here all the way around. So I want to see that you can figure out what that angle is, right? This angle, the standard angle, should be something in quadrant 3. So what I recognize is that 180 degrees plus my reference angle together equals this orange angle. So I've got like this half circle, that's 180, plus an additional little bit of the way more, but that little bit is the green angle. So together, 180 plus my reference angle equals that standard angle. So I know what the reference angle is. I'm just going to add 180 to it. So 218.66 would be this angle. All right, we did that on Tuesday, but I'm just wanting to make sure you're okay with that for today. We'll do one more just to make sure. So if I'm plotting the point 1, 6, picturing a coordinate grid, 1, -6 is putting me here-ish, and then I'm going to go from the origin. So it's that line there. And if I wanted to make a reference angle, I need to make sure I'm using the x-axis. So you're not using the y-axis. It's always the x. I'm not going to use the one on the left because this angle is on the right. So I'm going to use this axis and drop it down. So it's just like a really skinny long triangle. All right. What I know about that triangle is I went to the right 1 unit and down. I didn't go diagonal. I went down 6 units. So this is -6. So the side lengths of my triangles are the numbers in the coordinate book. One of the legs of the triangle is 1, the other one's 6. So if I want to find the hypotenuse, so it looks like it's going to be root 37, 36 plus 1. And then this would be your reference angle. Your reference angle is the corner angle. So using SOHCAHTOA, sine is the opposite of that green angle over the hypotenuse. And cosecant is just flipping that fraction. All right, and then I have to rationalize that, which I'm going to skip the step where I show it and just jump to what it is. For space sake here. Cosine is adjacent, which is 1 over the hypotenuse. And if I flip that, I get root 37 over 1, which is really just root 37. If I rationalize this, I get root 37 over 37. And then tangent is opposite over adjacent. And if I flip that, you can just write that as -6. If I flip that, I get 1 over -6. Right, all of that's coming from the two sides of the triangle. The two sides of the triangle are coming from the point. And then I want to calculate the theta. Now this is a little tricky because when I'm doing the tangent inverse, I'm picking tangent because tangent's the only one without a root. You don't have to pick tangent, okay? But if I'm going to pick tangent, I'm going to do the tangent inverse of 6 and not negative 6. We talked about that a little bit on Tuesday. The reason I'm not doing negative 6 is SOHCAHTOA is talking about right triangles, and having a side length of negative 6 doesn't make sense in terms of triangles. That's just helping us with direction. It's not the actual side length. If you do the tangent inverse of negative 6, you're going to get a negative number. So I'm just doing it of 6. It's the same number, okay, but we're going to use the positive one. So 80.54 is my reference angle. And I'm in quadrant 4, so when I'm thinking about my standard angle starts here and goes to that red. So you can see my standard angle plus that little bit of green is going to get me through the full circle. So my standard angle plus my reference angle equals 360. Each quadrant has its own rule. You can memorize the rules or you can use the picture. Your choice, right? But together they equal 360. So if I have this one, I can just subtract it from 360 to get S. So I'm just going to take 360 and subtract that 80. So my standard angle would be 279.46. We're going to do more of that today, but it's not going to be with a coordinate point. So your given information is going to look different. The process is going to be the same. It's just what you start with is going to look different. All right? What you're going to start with today is one of these 6 things. So I'm going to tell you, like, sine is 3/5. And that gives you something in the triangle. You got to figure out what it gives you. All right? What's wrong? Did you get a different answer?
Yeah, I got like 260.
Did you get the same? Did you get 80?
Tangent
inverse of 6. You got 80.53?
Yeah, you did it wrong. I did it in the wrong axis.
Got it, okay. All right, so in your toolkits, what we're doing today, same idea, different piece of information. This is on page 3 of your toolkit. You can see the picture looks the same as what we were just doing, right? We're going to ultimately do the same thing, but we're not given a coordinate point. We're given something else. So this one says, find the remaining 5 trig functions by using the given information to construct a reference triangle. Here's the information. I know that sine of theta is 3/7 and tangent theta is less than 0. So let's just start with what we know. If sine of theta is 3/7, then I can already fill in one of those blanks, right? Sine of theta is 3/7. And I can also do this one. If sine of theta is 3/7, then cosecant of theta is 7/3. Any ideas of what else I can do from that out of these blanks right now? There's one more thing. If I wanted to solve this equation right here, to get theta by itself, how could I get rid of the sine? When you're solving for an angle, how do you get rid of the trig function? There's a button on your calculator for it. I can already find the reference angle before I do anything else. If I have a trig function, sine, that has a button on the calculator, then I can solve the equation. So I can do the sine inverse of 3/7 and find that reference angle already before I even have the triangle. So let's see what it is. Make sure you're in degree mode. Sine inverse of 3/7. 25.38. And I haven't even done anything with the triangle yet, right? So I can get all of that just from that first piece of information. But I want to draw a triangle because it says reference triangle. So I have to figure out, well, with a 3/7, where am I going to go? This is where all students take calc comes in. I'm going to just jot this up here. All students take calc. Sine of theta is 3/7. Sine of theta is positive, right? 3/7 is a positive number. Where is sine positive? Which two quadrants? 1 and 2. A and S. A for all, S for sine. So I'm going to draw my triangle in one of those two. I don't know which one until I look at this information. This says that tangent theta is less than 0. So tangent theta is negative. Well, tangent is positive in A and T. So it's negative in 2 and 4. So what those two things have in common? Quadrant 2. So I am going to draw a random angle in quadrant 2. I don't care where you draw it, right? But from the center out, you're going to draw something in quadrant 2. We did some like this. I mean, we just did positive and negative, so I just have to take the fact that that's positive. We did something like that on Tuesday. All right, so now I know that I'm somewhere in quadrant 2, which technically you could fill in the standard angle from here. Because think about it. We've got the reference triangle like this, and I know that this angle is 25. So can I figure out what that one is? What's the relationship between the red and the green there? They make 180, right? So I can figure out this standard angle already without knowing anything else, right? I know that together my standard plus my reference equals 180. So if I know my reference, then I can get my standard. So I'm just going to do minus 180 from what I got here. So $154.62. And I didn't even fill in the sides of the triangle yet. So I can get all of that information just from those two things. The only thing I can't get from those two things is these. Because sine is opposite over hypotenuse. So I have the opposite side and I have the hypotenuse side. What I don't have is the adjacent side, and cosine and tangent require the adjacent side. I need the third leg of the triangle. So I have to solve for that. It's the only thing you really have to solve for without that given information. So let's think about what we have. If this is my angle, I have the opposite side length of that because sine is opposite over hypotenuse. So I have the opposite side is 3 and the hypotenuse side is 7. Sine is opposite over hypotenuse. So could I solve for the last leg? Pythagorean theorem, right? So 3 squared plus, we'll call it like x. This would be that side length there. Equals 7 squared. So we end up with 49 minus 9. So we're going to get the square root of 40 for that third side length. I'm skipping steps, right? You can square 3, that's 9. You can square 7, that's 49. Subtract, that's 4. Square root it. So 44 root 10. 2 root 10 is this remaining side length. I need that 2 root 10 to do anything with cosine and tangent because now I have the adjacent side length. So cosine is adjacent over hypotenuse. Did I miss anything on that? All right, let's say I didn't miss anything. We'll go back to it. All right, so if I flip that, 7 over 2 root 10, the flipped of that, right? And so I'm going to rationalize. The top is 7 root 10. The bottom is 2 times the square root of 100, which is 10. 2 times 10. The bottom is 20. Tangent is opposite over adjacent. And cotangent is the flip of that. And I'm just going to rationalize this one. 3 root 10 over 2 times root 100, which is 2 times 10, which is 20. All students take calculus. In quadrant 2, sine is positive, cosine is negative, tangent is negative. So sine's positive, these should be negative. So when I said, did I miss something? I missed something. Because I have that cosine is positive 2 root 10 over 7. And I have tangent is positive 3 root 10 over 20. I missed a negative somewhere. Where's the negative go? This is to the left, right? So if this were a coordinate point, it would be negative x, positive y. This should have a negative sign on it. If you forget it, that's okay. You can do it at the end. I'm just going to go back and I'm going to put negative signs on the cosines and the tangents. The x value is technically negative over there. It's to the left. It's the same but different. You're starting with something different, but the process of that all is the same. We're doing the same stuff. All right, let's look at the next one. Secant theta equals 3, sine is greater than 0. Okay, so here's what I know. Secant of theta is 3. Right, that piece of information is given to me. So if it's 3, what is it as a fraction? 3 over 1, yes, which means this one is 1/3, right? So like, if I want that one, I have to flip this one. In order to flip this one, I created a denominator of 1. So cosine's 1/3. From here, if I have one of these 3, then I can do this. Cosine inverse of 1/3. Right, as long as I have a sine, a cosine, or a tangent, I can find that angle. So cosine inverse of 1/3, 70.53 is my reference angle. So I have to know what quadrant I'm in. Secant of theta tells me that cosine of theta is positive. Because if secant was 3 over 1, then cosine was 1 over 3, and both of those are positive. If the reciprocal's positive, the other one's positive, and vice versa. So that's the piece of information that gives me. And sine theta being greater than 0 is telling me that sine of theta is positive. So I just have to figure out where I'm at. Cosine is positive in 1 and 4. Sine is positive in 1 and 2. So what do they have in common? 1. So my angle is somewhere in quadrant 1. And I know if I can make my reference triangle, I'm on the right-hand side, so I'm going to use the right-hand x-axis. That's my reference triangle. And I know this angle right here is 70.53. So what's this angle? 70.53, right? The same. Quadrant 1, reference and standard are the same thing. If that's not making sense to you, you got to work on memorizing the rules. We had a page where there were a rule for each quadrant. You either have to memorize the rules or understand that visually that's the same exact angle. So this is 70.53. The only other thing I need to do is I need to find sine and tangent. Well, cosine is adjacent and hypotenuse. So I'm missing one of the legs. I'm missing the opposite leg, so I need to figure out what that one is. So cosine of theta being 1/3 is telling me the adjacent and the hypotenuse leg. So the adjacent leg to this angle is the one next to it, and the hypotenuse is this one. And what I know about coordinate points, like if this was a coordinate point right here where those things met, what I know about coordinate points in quadrant 1 is that I'm going to the right, which is a positive x, and up, which is a positive y. So everything's positive here. I don't need to worry about putting a negative symbol on any of that. And I just want to find that third side length. So I'm just going to call it x squared because I have the hypotenuse, so that's going to go on the other side of the equation. So 9 minus 1. X squared is 8. So x is root 8 or root 4, root 2. Or 2, root 2. And that's positive because, again, that point is in quadrant 1. It's a positive x and it's a positive y. Right 1 up to root 2. And so sine is opposite over hypotenuse. Cosecant is the reciprocal of that. I'm just rationalizing to get the root out the bottom. So this becomes 3 root 2 over 2 times root 2 times root 2, which is root 4, which is 2, so it's 2 times 2. That's a 4. Tangent is opposite over adjacent. So cotangent is flipping that. You don't need to write the over one for that one. And I'm going to rationalize here. So we have everything. You guys get the idea there? I think there's one more, but I'd rather you practice on your own than keep doing them for you. So I'm going to have you try some, and then I'll post the answers towards the end of class here. So you are going to try in your workbook page 8. Nope, sorry. Page 17. I don't know what that is. Try page 17, 11 through 13. Tell me what that looks like. Yeah. All right. Page 17, 11 through 13. Now, your directions say calculate theta in degrees and radians. I'm crossing off the radians. I don't care if you can calculate the angle in radians. I want you to calculate the angle in degrees and find the standard angle. So you'll have a reference angle and a standard angle at the end like we did. So those two blanks, one will be the reference angle, one will be the standard angle. So I just changed the format a little bit here. All right. So try these out. I will post the answers towards the end of class. It's not this one. It's page 17, 11 through 13.